Hi everyone! Welcome again to my channel, Math is Fun channel. This is an educational channel to help you understand and learn more about mathematics. And this is an educational channel, as I have said, to help you improve your performance in mathematics. This is intended for those students who are really seeking for help about mathematics, and especially those who are doing their online classes out there, and also those who are answering their modules. Okay, so this is a very helpful video for you, and this video is really meant for you. Please do not forget after watching the video to subscribe my channel, and also to share this one, and of course to press the like button after watching the video. So that's clear, right? So now we will go right away to our discussion for this video presentation, or in this video rather. So now I will be talking about still part of the real numbers, but we will focus on Chereng. Oh, corny. Comparing irrational and rational. Sorry, I have to change this one. Comparing irrational and rational numbers. So how do we compare irrational and rational numbers? Are you ready? Okay, so compare and rational, our main objective or objectives for today's video discussion are compare rational and irrational numbers. That's the first. The second, order rational and irrational numbers on a number line. So now let's have a review about real numbers. We have learned that real numbers are every number. Therefore, any number that you can find on the number line are real numbers. And real numbers have two categories. We have the rational and irrational numbers. So what does it mean? The number line goes on forever. Every point on the line is a real number. And there are no gaps on the number line. Between the whole numbers and the fractions, there are numbers that are decimals, but they don't terminate. Or, yeah, they don't terminate and are not recurring decimals. They go on forever. So, two kinds of real numbers. As I have said, we have the rational numbers and irrational numbers. Are you ready to define them? Okay, as a recap or recall, when we say rational numbers, these are numbers that can be written in, sorry, okay, rational numbers are numbers that can be written in fraction form, a over b. So examples of rational numbers are 16, 1 half, 3.56, negative 8, 1.33, so on and so forth, and negative 3/4. So when we say irrational numbers, these are numbers that cannot be written as a fraction of two integers, as I have said in the previous video. And of course, irrational numbers written as decimals are non-terminating and non-repeating. So examples of irrational numbers, we have square roots of non-perfect square numbers. So, and square root of 4 is not irrational numbers because number rather because it equals 2, which is rational. That's why square root of 4 is considered as um, rational number. An example of irrational number is square root of 17, since 17 is not a perfect square. And of course, another example for irrational numbers another example is pi. Have you ever remembered the pi? Okay, pi. Wow, delicious. So pi is part of irrational numbers. So now let's try to compare rational and irrational numbers. So when comparing different forms of rational and irrational numbers, convert the numbers to the same form. Again, so that it will be easier for us to order or to compare the rational and irrational numbers, it's very important for us to write them in the same form if their forms are different. So we write it as same forms. Is it possible? Yes, it is. So example, compare negative 3 and 3 over 7 and negative 3.571. So to compare, we can convert negative 3 And 3 over 7, this one, the mixed fraction, we can rewrite it in decimal form, which is negative 3.428571. And that gives us, we can compare right away that negative 3.4, we can compare negative 3.428571 and negative 3.571. Okay, so we can say, or we can compare after rewriting them, or converting the mixed fraction into decimal form. We can write, or we can compare negative 3.428571 as greater than negative 3.571. Okay, so so that's it. So now let's try to practice compare, use less than, greater than, or equal to compare the numbers. I want you to try it. I'll give you time. 1 minute. Go on. Sorry. Okay, so after that, a square root of 27. Square root of 27 can be solved or expressed in decimal as 5 point, or approximately 5.196. So as you can see, this is 5.196 is less than 5.35. So we can use the less than symbol. So that's how we compare the rational and irrational numbers. So this one, 20% can be converted into zero point 0.2 in decimal, so that we can right away identify which is greater. So we can have zero point 0.2 is less than 2, obviously. 8 over 9 can be written as decimal form. We can have it 0.88. And of course, 80% can be written as zero point 0.8. And as you compare them, of course, 0.88 is bigger than zero point 0.8. So that's how you do the comparison between a rational number and irrational numbers. So very easy, right? You don't need to do a lot of math here. So now, or solving rather. So now let's go to the next, ordering rational and irrational numbers. So to order rational numbers and irrational numbers, convert all of the numbers to the same form. It's up to you. Okay? You just convert them in the same form so that it will be easier for you to order them. And you can also find the approximate locations of rational and irrational numbers on a number line. So to do this, let's have an example. Order these numbers from least to greatest. Starts from the least to greatest. So we have the given 1/4, 75%, 0.04, 10%, and 9 over 7. So I want you to do it on your seat. On your seat, rather. Sorry, I lost my voice. So we can have it 1/4 becomes 0.25, 75% becomes 0.75, 0.04 stays 0.04, 10% becomes 0.10. 9 over 7 becomes 1.2857142. So in short, it's very easy for us, and it is more convenient to really convert them into decimal before we order them or compare the rational and irrational numbers. Correct? So now we can identify and arrange them from least to greatest. We have 0.04, 10%, 1/4, 75%, and 9 over 7. So easy, right? So now real numbers in a number line. For irrational numbers, I'm showing this picture to you so that you will realize that you can also plot the irrational numbers in a number line. As you can see there, these are this shows the graph of the rational numbers, or location of the irrational numbers in a number line. Another thing also for the rational numbers, okay, in a number line, you can see there that that rational numbers can also be located in a number line. And of course, to combine them all, rational and irrational numbers can be located in a number line since they are part of real numbers. So a real number can be are all numbers that can be found in a number line. So that's it. So I want you to remember that one and hope you'll not forget it. So math is fun. You can now say that math is fun after comparing irrational and rational numbers. So sometimes in life, we really have to consider the beauty about mathematics because it's not really difficult. It's the problem in here in our mind. That's why we have to change our perspective that math is not a difficult subject, but it's easy, fun, and interesting. So math is fun. Please do not forget to subscribe my channel and of course to share my channel or my video discussions to your friends. Have a good day, everyone. Have a nice day. Thank you for listening. See you in my next